So I'm going to be teaching you about acceleration, okay? And the first thing that you need to know about acceleration is that it's a vector quantity, but you don't know what vectors and scalars are, right? So a vector quantity is simply defined as a quantity that is defined by magnitude and direction, okay? Magnitude and direction. That means that in order for the quantity to be fully defined, it has to have a number and it has to have a direction, like up, down, west, east, or something like that. A scalar quantity is a quantity that is defined fully by magnitude. So it does not have to have a direction attached to it. It can just be defined by the number. However, both have to have units. Units are not part of the vector scalar quantity. So, okay, so an example of a vector is velocity. Would you be able to tell me why? It's okay if you can.
Okay, is it because velocity has magnitude and direction?
Yeah, and do you know what the difference between velocity and speed is?
I kind of know, but I don't really know how to say it, so I don't know the actual definition of both of them.
Can you tell me what you know?
Okay, so I think speed is just like the distance it takes.
Okay.
Like, is speed a scalar quantity?
No. Speed is scalar.
So speed is just magnitude.
Velocity, first of all, okay, velocity is the rate at which an object changes its distance. And I know that sounds complicated.
Wait, what is it again?
Velocity is the rate at which an object changes its distance.
Okay.
Okay? So what that basically means is, you know the units for velocity are meters per second, right?
So meters per second?
Yeah, units for velocity are meters per second, right?
Yeah.
Meters per second. Same units for speed. Meters per second, you know that's seconds is the time. Meters is the distance.
For velocity and speed.
Yeah, for velocity and speed, but meters is the distance, speed is the time. So it's distance per time, right?
Mm-hmm.
Except that velocity, and that's where they're similar, except that velocity also has to be defined with the direction. So speed does not depend on direction. Speed is just the number. Speed could just be 300 meters per second, like that.
So what is speed though? Like, how would you define speed?
Speed is the rate at which an object changes its distance, the same. But speed is a scalar quantity, and velocity is a vector quantity. Now, velocity is dependent on direction.
Mm-hmm.
So an object can have a constant speed, but not a constant, by the way, means just not changing, the same. An object can have a constant speed, but not a constant velocity. Can you tell me why?
Because in order for it to have a constant speed, speed is a scalar quantity, so it just means it's just by magnitude, but it doesn't have to have the velocity, because velocity is a vector quantity, so it requires magnitude and direction?
No, just an object can have a constant speed, but that same object with the constant speed might not have the same constant velocity, because the speed, it could be changing direction at the constant speed. It could be going in a circle, which means the direction is always changing, right? At a constant speed. If it's at a constant speed, the speed is constant, obviously, right? But the velocity is not constant because the direction is changing.
So if it is a vector quantity, then it has to have the same
quantity.
direction? If it's a vector quantity, it has to have the same direction.
And if it's a vector, vector just means it's dependent on magnitude and direction. Now we're talking velocity is a specific example of that.
Oh.
Okay? So in order for an object to have constant velocity, it has to be going at the same speed in the same direction. okay? In order for an object to have a constant speed, it just has to be going at the same speed. Direction doesn't matter.
But if it is a vector quantity, it has to have the same speed as
No. Vector.
Oh, okay, velocity.
Vector just means that it's magnitude and direction. Okay?
Velocity is an example.
Velocity is an example, speed is an example of a
Okay.
scalar quantity, okay? Okay?
Yeah.
So acceleration, which is basically what I'm teaching you about, is a vector quantity. That means it is dependent on magnitude and direction, right? So acceleration is defined as the rate at which an object changes its velocity.
Okay.
Okay, so acceleration is the rate at which an object changes its velocity. Basically, it's the change in velocity. That's basically what it is. Change in velocity as a unit of acceleration is the change in velocity per unit of time.
Is it measured as this?
And the unit is not going to be meters per second. The unit is going to be meters per second squared. I'm going to show you how we get that, okay? Remember how I said acceleration is the change in velocity per a unit of time, right? So delta, when I write delta, it just means change. The triangle symbol is a change.
Delta equals change.
That's not important though. But delta V, which means change in velocity over time. Change in velocity per unit of time, okay?
Is that acceleration?
This is how you get acceleration, the change in velocity per unit of time.
Okay.
Okay? And then so what are the units for velocity?
The units for velocity are m and s.
No.
Meters per second.
Meters per second, right? You're never going to say m and s.
Oh,
You're
meters
going to
per
say
second.
meters per second. Meters per second. What's the unit for time?
T.
No.
Oh,
What's-
seconds.
Seconds.
Okay.
T is just
The
the
variable,
the
yeah.
symbol we use. So these are the units. And this is basically equal to this, right?
Okay, wait. So A equals that.
No,
And so
no,
then-
I'm just showing you how to derive the units.
Oh, okay.
So
But how did
this,
you get this?
because meters per second is basically meters divided by seconds.
Yeah.
Divided by seconds.
Oh, so that's
So
why I wrote
this
it. So
is
M
equal
divided by
to-
S divided by that.
This is equal to meters per second squared. This is going to be the unit for acceleration.
Oh, so this is just how you get that.
Yeah,
This, okay.
but you don't need to show all this work ever. I'm just showing you this is how we get meters per second squared. This is always the unit you're going to use for acceleration. Okay?
Yeah.
So that's always the unit you're going to use for acceleration. But the formula for acceleration, we said, is the change in velocity over time.
Wait,
right?
isn't this the formula or?
No. This is all just how to derive the units. This has nothing to do with the formula.
Okay.
Okay? This is the formula. Change in velocity over time.
Mhm.
Okay? Can you tell me, change in velocity. How do you get the change in something? You're going to take the final minus the initial, right? Do you understand why?
Yeah, because to find the change, then you have to find the end point and the starting point
Exactly.
and subtract it.
Exactly. So, but you can never, this is important, you can never take initial
So the
minus
first-
final.
first
It's
number?
always the end minus the beginning.
Does it,
Always
like,
final
Is
minus
the end
initial.
bigger than?
That depends. That depends on the
So
problem.
it
You
doesn't
can always
matter.
end up with negative.
But you always subtract the second number first, like this.
The
minus
second,
that.
see, look, you can't just say second, because in a problem you might get the original, you might get the final velocity, that might be the first number you get. But you always have to read the problem. And you have to remember, it's always final minus initial. It's never initial minus final. Always final minus initial.
For acceleration.
So we're just gonna change this. Instead of delta v over t, we're gonna replace delta v, which is change in velocity. What can we replace that with?
Wait, why are you changing it then?
Because we're just making it easier.
Okay, so delta v.
We said change, right?
Mm-hmm.
So what is change? It's gonna be final minus initial. So that's gonna be final velocity. That's the symbol we're gonna use for final velocity. V final minus v naught. We just call that v naught.
Okay.
Initial v velocity all over time.
Divided by t. Okay.
And this is the new equation.
So
Okay? And also, okay, let's just wrap this up. If acceleration is change in velocity over time, there are 3 ways you can accelerate. There are 3 ways you can change velocity, right? One of them is to speed up.
So you can change velocity in these 3 ways.
Yeah, you can accelerate in these 3 ways. You can speed up, you can slow down, and the third one is that you can change direction because you're changing velocity, not speed, correct?
Yeah, so
You can speed up, slow down, or change direction. Those are the 3 ways you can accelerate, right? So the important thing to remember is that even if the speed is constant, if you're changing direction, it means you are accelerating. Okay?
so if you change direction, you're always accelerating.
If you change direction, you are accelerating. Okay? Even if the speed is constant, you're accelerating. Okay?